Siemens opens 1.25 megawatt microgrid at North Carolina Power Hub. Siemens has commissioned a 1.25 megawatt microgrid at its U.S. electrification and automation headquarters in Wendell, North Carolina, as manufacturers look for more control over energy costs, reliability, and on site generation. The system brings together a solar photovoltaic carport array, a 3.9 megawatt hour battery energy storage system, and digital energy controls. Under certain operating conditions, Siemens says the microgrid can meet the facility's full electricity demand using renewable power. It can also disconnect from the utility network during an outage, allowing parts or potentially all of the campus to continue operating independently, depending on available solar generation, battery capacity, and site demand. The installation is one of the larger industrial solar and storage microgrids connected to Duke Energy's distribution system in the Carolinas. In addition to supporting the Wendell campus, it serves as a live demonstration of equipment and software Siemens supplies to industrial, utility, infrastructure, and commercial customers. Microgrid supports manufacturing continuity and energy management. The Wendell facility produces medium-voltage equipment used in electrical infrastructure projects. Maintaining production is particularly important as utilities, data centers, manufacturers, and other large energy users invest in grid upgrades and electrification. An extended grid interruption could affect production schedules and delay equipment deliveries. The microgrid is designed to reduce that exposure by combining on-site generation with stored electricity that can be used when utility power is unavailable or when site demand changes. Its control system determines when electricity should be generated, stored, consumed, or exported. This gives facility operators a more detailed view of energy flows and allows them to adjust the system around production requirements, building loads, and utility conditions. The project primarily uses Siemens equipment, including the CCAM 8000 microgrid controller, Ciprotec protection relays, low-voltage switchboards, bolted pressure switches, and fire protection systems. Kako string inverters convert electricity from the solar array for use across the campus. Siemens has also connected its Desigo building management platform and Electrification X cloud analytics to the microgrid. The integration brings data from generation assets, battery storage, buildings, and electrical equipment into a broader energy management environment. Operators can monitor solar output, storage levels, facility demand, and equipment performance while coordinating consumption across the site. For industrial users, this type of integration may be as significant as the generation assets themselves because it links energy decisions with operational needs. The campus's VersiCharge electric vehicle chargers are included in the system. Charging demand can be managed alongside other site loads, and vehicles can use electricity generated by the solar array. Visitors to the facility's Customer Experience Center can also view charging activity and dynamic load management in real time. Brian Dula, president of Siemens USA Electrification and Automation, positioned the project as a practical example of managing electricity from generation through end use. The site allows customers to examine how the company's hardware, controls, and analytics function together in an operating industrial facility rather than through a standalone product demonstration. Wendell project offers a test case for industrial energy resilience. The microgrid can take part in net energy metering, enabling surplus electricity to be exported to Duke Energy's network. Actual exports will vary based on solar production, battery operating strategy, and the amount of electricity required by the facility. For Siemens, that capability may improve the project's economics while allowing unused generation to support the local distribution system. For Duke Energy, projects of this kind provide another example of how customer-owned energy resources can interact with the grid as electricity demand grows in North Carolina. Vinu Ganta, Duke Energy's Vice President of North Carolina Regulatory Affairs and Policy, linked the project to the utility's focus on maintaining reliability at a manageable cost. Duke Energy and Siemens have an established commercial relationship in the region. Siemens reports that the microgrid, together with other efficiency measures, has helped the Wendell campus achieve carbon-neutral operations and reduce its reliance on grid-supplied electricity. The company also reported an annual grid energy reduction of 2.5 megawatt hours. However, it did not provide a detailed calculation or identify how much of that reduction came directly from the microgrid rather than from other efficiency initiatives. That figure may require further context, particularly when compared with the scale of the generation and storage assets installed at the site. The project forms part of a wider expansion at the Wendell headquarters. Siemens has added manufacturing lines, training classrooms, conference facilities, and an interactive customer center. The company has also hired hundreds of employees at the location in recent years and expects workforce growth to continue through 2028. A related workforce development initiative is planned with Wake Technical Community College. Siemens is supporting a proposed campus microgrid intended to improve power reliability while giving students practical exposure to energy systems, automation, and electrical infrastructure. For manufacturers assessing microgrids, the Wendell installation highlights a shift away from treating solar panels, batteries, and building controls as separate investments. The project instead combines them as one operational energy system. The business case will vary by site, tariff structure, and production profile. Even so, the ability to maintain critical loads, manage demand, and coordinate distributed energy resources is becoming more relevant as industrial electricity use rises and grid conditions become harder to predict.